More optimization problems. Here we're asked to find the point P on the curve y equals x squared that is closest to the point 18, 0. What is the least distance between P and 18, 0? So there's actually two questions. They want to find the point on the curve that's closest to the given point of 18, 0, and what is the least distance between P and 18, 0. Well, the first thing that we have is that y equals x squared. One can think of this as a constraint. And what we want to do is minimize the distance between any point on this curve and the point 18, 0. So let me call it d, the distance between a point xy and the point 18, 0 looks like this. It's the square root of x minus 18 to the second power plus y minus 0 to the second power. It's the square root of all of that. Now, this is what you would call the objective function, this d. Now notice by the constraint y equals x squared, I'm going to replace the y in my distance formula with x squared. And I'll get d, and now it'll be a function of x, so I'll call it d of x equals the square root of x minus 18 squared plus, so if I replace y with x squared, then I'll have x squared squared, that'll be x to the fourth. Now, there's a bit of controversy in this next step. I remember when I first saw this, I couldn't believe you were allowed to do something like this, but I'll sort of explain something here. Let me call it a note. If you're looking for the smallest or biggest of something, or you're usually looking at things less than or greater than, things of that nature. So if I had, say, an inequality of this nature, L is less than or equal to M, and you knew that L and M are both positive numbers, then it shouldn't surprise you that L times L would be less than or equal to M times M. Or in other words, L squared is less than or equal to M squared. All right, what that means is that when I square both sides, I preserve the order. It's still, the L side is still less than or equal to the M side. Now, what I'm looking for when I'm doing this distance formula is I would like to find a number, the least distance. Let's just say I'm going to have a number like L is less than or equal to D, right? And so that L squared is less than or equal to d squared. Well, that keeps the same sort of a thing. That means that if L is the least amount, then L squared will still be the least amount for squaring it. And then if I can locate where that happens, I can finally find out what the actual L was. What I'm getting at is this. Taking derivatives of a square root and all this kind of stuff as a function d is not pleasant. So people go through the effort of saying, well, I'm permitted to pick a new function. I'm going to call it script d of x, and that's going to equal d squared of x, which equals x minus 18 squared plus x to the fourth. And the reasoning is, since squaring things does not change order, then I can work with this new function a lot easier than I could have with the square roots. So in fact, when I find whatever x value solves this problem will be the x value that will solve the original one. So let me take the derivative of my new script d, and that is not looking good. Come on, script D. Script D prime of x equals, remember, take the exponent down in front, so I have 2 times x minus 18. The derivative of x minus 18 via the chain rule is 1 plus 4x cubed. And remember, you want to set this thing equal to 0. So I'll get 4x cubed plus 2x minus 18 equals 0. Now typically you don't have to solve a cubic because the formulas for that are just never given to students. They're just too horrible looking. However, if the number turns out to be good, I might be able to do something with it. First thing I am going to do, though, I notice I can divide everything by 2 here and rewrite this equation as 2x cubed plus x minus 18 equals 0. Let's take a look at it on the calculator. Let's graph it and see if it has any easy solutions. So I'll go to y equals, oh, well, I've already put it in there. Let me start with zoom 6. And according to this, it has one place that it crosses, at least in the standard viewing rectangle. Now, you can use your calc mode, second calc, and go to number 2 for 0. Now what it wants you to do is pick a left and a right bound. We've done this before, but I try to pick them close to where it looks like it's intersecting the x-axis. So I see the little star, the little cursor shows up right now. I'll hit enter, it's to the left. And now it says go to the right. So I'll go a couple of notches to the right, enter, and then the last thing it wants is a guess. So you can back up one notch and be in between, that'll work as your guess. And it says 0 is 2. Just 2. Nothing special, just the number 2. So with that in mind, since 2 solves this, I can use synthetic division to factor this thing completely. Remember, you put the coefficients on the first row of this, so I'll have a 2. There's no x squared term, so don't forget to put a 0 for the x squared term. There's a 1 in front of the x and a negative 18. And remember how this works. You draw a line, give yourself space for another row, drop that leading 2 down, and then you start multiplying. 2 times the 2 in the box is 4, and then 0 plus 4 is 4. 4 times the 2 in the box is 8, and then 1 plus 8 is 9. 9 times the 2 in the box is 18. Of course, that makes 0. We knew that was going to happen. But it tells me something more. 2x cubed plus x minus 18 is the same thing as x minus 2. And underneath the third row of the synthetic division gives the coefficients for the other factor. That's 2x squared plus 4x plus 9. So far what I had then is I set it equal to 0, x minus 2 times 2x squared plus 4x plus 9 equals 0. I already have x equals 2 as one of my answers. The rest of it I can get via this quadratic formula. So I'll have 2x squared plus 4x plus 9 equals 0. Make that 0 better looking. Then I'll use the formula x equals negative 4 plus and minus 4 squared minus 4 times 2 times 9. All of that is over 2 times 2. And I can see right now, inside of the square root, I'm going to have 16 minus 54. That's a negative number inside of the square root. I think that's actually not, that's 72. It doesn't matter. 16 minus 72 is still a negative number. So this number is not in R. Not a real number. That means the only number that I need to try here is x equals 2. So, how do I know if x equals 2 actually minimizes this? When they said, let's go back to the statement of the problem. It said, find the point on the curve y equals x squared that is closest to a certain point. And then, what is the least distance? There's no indication that x and y, the only constraint is that y equals x squared. I don't have an interval to work with here. That means the x values can be anything from negative infinity to infinity. But we should be reasonable about this. What you're actually trying to do, let me draw a picture of what we're getting at here. You have parabola, y equals x squared. I drew it poorly, but then you have a point, 18, 0. And I'm trying to find some point, the point P they call it, on that parabola that is closest, where the distance is the least here. So I have an open interval, if you will, negative infinity to infinity to try from. So one of the ways we can do it is this. Let me go back to my script d prime. There it was 4x cubed plus 2x minus 18. So my script d prime, that was 4x cubed plus 2x minus 18. One of the things you can do is the second derivative test. Let me take script d double prime of x equals 12x squared plus 2. One thing I can tell you about this, if we're talking only real numbers, 12x squared is not negative. That means that 12x squared plus 2 is always going to be at least 2, no matter what. It's greater than 0 for all x. What does that tell you about d script? This means that d of x is concave up for all x. Well, that means that the point that we found, this thing isn't only a local minimum, it's the absolute minimum, because we have only one critical number. The function is concave up throughout its entire domain. The one critical number will locate for us a local minimum. So if this is at the bottom of a concave up curve, it's got to be the absolute minimum. So we have an absolute minimum. At x equal to 2. You don't believe me? Let's go ahead and put the d. I don't care if we put the script d or the original d in the calculator. I'll put the original d in the calculator. Put that whole ugly thing in there. Square root x minus 18 squared plus x to the 4th. And I'll do as I did before, zoom 6. Now it looks as though there's nothing to see here, but if you hit your trace button, it will tell you where the graph is, where you can find graph at. For example, when x equals 0, y is 18, so I'm going to have to increase my y values. But you can see it starts to drop down. So let me make my window, where was it? Let me make my y max equal to 25. And then let's regraph. Now you can see this thing comes down, 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 and it certainly looks like its min might be 2. You can actually have your calculator check it for you. You can go second and then calc, and you can actually use option 3 for minimum, and then it plays the same game with you as it did for the 0. You do a left bound, and then make sure you move the cursor to the, obviously to the right of where the lowest point is. Enter. And then you move somewhere in between. The closer you do it, the faster it'll actually find the answer. And you can see that it has 1.99. It's so many nines that this is your calculator telling you within its error. It's trying to give you 2, but it had to round somewhere. And it can't give you exactly 2, but it's trying to do that. What's cool about that is we have an answer that is more accurate than the calculator is capable of giving us. So, anyways, we are certain that an absolute minimum occurs at x equal to 2. So, what is the point? That's what it was. What point is closest? Well, if x is 2, if x equals 2, y equals 2 squared, which equals 4. So the point 2 of 4 is P. And then what was that distance? That was the second part. That distance would be, then I'll just plug in the regular distance formula. I have x was 2, so I have 2 minus 18 squared plus 4 minus 0 squared. That equals negative 16. If I square that, will be positive 256. And then, of course, 4 squared is 16. That ends up being the square root of 272. I personally don't care if you would leave your answer like that or if you try to simplify it. I really do not care. And when it comes to these kind of problems, I almost never, and I'm pretty sure almost never, ask you to give me an exact answer. So you could have done the whole thing on the calculator to begin with. But if I was a fiend and I had to know how this simplified, the first thing that I would take out of here, did you notice that this was 16 squared plus 16? I could take a 16 out of the 256 and a 16 out of the 16. So I'm not going to do this radical 272. If I wanted to simplify, I would do this business. I would do 16 times 16 plus 1. And then I can factor out a 16 in front, and I'll get 4 radical 17. That's the exact distance.